The moon is more than just a glowing companion in the night sky. It is a stabilizing force, a cosmic metronome, and an ancient architect of Earth's rhythms. But what if, in an instant, or perhaps never having existed at all, the moon disappeared? The question may sound like a whimsical thought experiment, but its implications are profound and far-reaching. To understand what we would lose, we must first understand what the moon quietly provides. Our satellite, born from a cataclysmic impact some 4.5 billion years ago, has governed Earth's tides, nudged our planetary tilt into stability, and perhaps even paved the way for life as we know it. Its presence is subtle, yet foundational. Remove it, and the equilibrium of our world begins to unravel, slowly at first, then with accelerating consequences. Begin with the tides, those rhythmic breathing motions of the planet's oceans. The moon's gravitational pull exerts a constant force on Earth's oceans, drawing vast quantities of water into bulging tides that influence not just shorelines, but entire marine ecosystems. Without the moon, the sun alone would raise tides only about a third as strong. This reduction would disrupt coastal ecosystems that rely on the cyclical ebb and flow of seawater. Many species, from crabs to coral, have life cycles intricately tied to tidal patterns. Their disappearance or decline would trigger cascading ecological effects. Over time, fisheries would collapse, coastlines would change, and entire biomes might vanish. The oceans would become quieter, more stagnant and less dynamic, a planetary pulse diminished. Yet tides are only the beginning. Perhaps the most critical and least understood function of the moon lies in its gravitational influence on Earth's axial tilt. Our planet spins with a tilt of about 23.5 degrees, an angle responsible for the changing seasons. The moon acts as a stabilizer, limiting the chaotic wobble caused by the gravitational pull of other planets, particularly Jupiter. Without the moon, Earth's axial tilt could begin to fluctuate wildly over geological timescales, perhaps ranging from near zero to 85 degrees. This means that over millions of years, Earth's climate would shift dramatically. Ice ages could deepen, tropical zones could move unpredictably, and entire regions could swing from temperate to inhospitable. Civilizations, if they managed to exist at all, would live in a state of long-term climatic uncertainty. The moon's absence would also subtly influence Earth's rotation. Today, the moon is slowly pulling away from Earth, about 3.8 centimeters per year, and in doing so, it is gradually slowing Earth's spin. This deceleration results in ever longer days, though imperceptibly so on human timescales. Without the moon, Earth's rotation would likely be faster, resulting in days that might last as little as 6 to 12 hours. The implications for wind patterns, weather systems, and the circadian rhythms of life would be profound. A faster spinning Earth would produce stronger Coriolis forces, amplifying hurricanes and altering ocean currents. Biological life, particularly organisms adapted to the 24-hour cycle, might evolve very differently or not at all. There's also the psychological and cultural dimension. The moon has inspired poets, artists, navigators, and astronomers for millennia. From ancient calendars to modern mythologies, the moon has served as a celestial guide and a symbol of constancy. Its phases helped early humans track time. It lit the night for travelers and inspired questions that led to science itself. Without it, early civilizations might have lacked one of their most reliable natural timekeepers. Our mythology would be poorer, our nights darker, and our sense of cosmic connection diminished. The absence of the moon would not just alter the mechanics of Earth, it would alter the story of humanity. With the moon gone, evolution itself may have taken a different route. Some scientists speculate that the tidal zones created by lunar gravity were ideal nurseries for early life, places where water met land, creating a cycle of hydration and desiccation that could have concentrated organic molecules into self-replicating systems. Without the moon, these vital intertidal zones might never have existed, or existed in a far less favorable form. Life may have emerged more slowly, or not at all. Even if life did emerge, the absence of stable conditions might have prevented the rise of complex multicellular organisms. The evolutionary tree would be pruned, its branches fewer and thinner. Technologically, the Moon has played a central role in our ascent into space. It was the first target of serious astronomical observation and later the first destination for human space exploration. The Moon served as both training ground and proving ground for space agencies across the world. Without it, space might have remained a distant dream far longer. The Apollo missions, so pivotal in galvanizing global interest in science and engineering, might never have happened. The Moon's proximity and relative accessibility offer an invaluable stepping stone to the rest of the solar system. Its absence would leave us adrift in ambition. Without a nearby celestial goal, the cultural and political will to explore space may never have reached critical mass. From a gravitational perspective, Earth would also subtly shift in its orbit over immense timescales. The Earth-Moon system acts like a binary planet with their shared center of mass affecting how the Earth moves through space. Without the Moon's influence, Earth's orbit could become more elliptical, increasing seasonal extremes. The loss of this gravitational dance partner would make Earth a more isolated body in the cosmos, more susceptible to perturbations from passing asteroids or gravitational nudges from distant planets. Meanwhile, the absence of moonlight would cast Earth's nights in deeper shadow. This darkness would have changed the behavior of countless nocturnal species. Many rely on moonlight to hunt, navigate, or mate. A moonless Earth would favor different evolutionary strategies. Bioluminescence might be more common. Predators and prey would have evolved heightened senses or different mechanisms for nocturnal survival. Even human culture would be affected. Nighttime activities would be riskier, less developed. Urban lighting might have evolved faster out of necessity. Ancient festivals and rituals, so often tied to the lunar cycle, might never have emerged. Yet, perhaps the greatest loss would be intangible, the sense of cosmic intimacy. The Moon is the only other world whose surface we can clearly observe with the naked eye. It is a constant reminder that we are part of a broader universe, reachable, mysterious, and yet close enough to touch. In losing the Moon, we would lose not just a celestial body, but a sense of orientation in the cosmos. Our ancestors may have looked upward less often, dreamed smaller, and feared the night a little more. So what if the Moon disappeared? The answer is not just scientific, it is existential. The Moon's gravitational grip, its rhythmic pull, its quiet guidance across billions of years has shaped not only the Earth but everything that calls it home. In removing the Moon, we unravel a web of connections between planet and ocean, between biology and environment, between knowledge and wonder. And in contemplating that absence, we're reminded of how even the most silent cosmic forces can be the most essential.